Hello. We're now up to Chapter 2 of Routing and Switching Essentials, or CCNA 2, and so we're going to look at static routing. So, we're going to look at the advantages of static routing and also the disadvantages. We're also going to look at how you configure static and default routes for both IPv4 and IPv6. We're going to look at a strange thing called floating static routes, but excellent backup routes. And then we're going to look at troubleshooting static and default routes as well. Okay, so how do we implement static routes? So, of course, last chapter we looked at how remote network routes can be learned, and one of them is dynamically from a routing protocol, but of course the chapter we're talking about today is manually, and so that's where the administrator needs to type in those routes. And of course the major downside of that is if the network changes, the administrator will have to type a different route in, and so it doesn't automatically update as per changes of the topology. So, dynamic versus static routing, basically configuration complexity, generally independent of network size, and so basically you just need to configure each router individually. They'll talk to their neighbors and they'll learn everything. So that's great. It doesn't get any more complex. But with static routing, I think I might have said last time, as you add networks, the number of routes static routes you need to type in will actually grow exponentially. And so it gets very big. And so it's not necessarily complex, but it's just a big administrative workload. So topology changes, as we said, dynamic routing will automatically adapt to topology changes, be they design changes or, of course, failures in the network. While with static routing, someone's got to change it. With scalability of the networks, so again, that's where dynamic routing protocols come up good. While static routing is only good for small networks, basically, because of that administrative effort required. So static routing is better for security because no network information goes over the wire. And so that's a downside for dynamic routing, but there are ways around it. Resource usage is another advantage of static routing because, it's very simple for them to update their routing tables. That's it. While when it comes to dynamic routing, you use bandwidth, you use memory, you use CPU, all of those things. And so it does use more resources. So predictability, well, that's, I suppose, an upside for static routing, but of course, how many people keep track of which way their packets go? Okay, so when should you use static routes? So smaller networks that are not expected to grow, stub networks, and so basically this is a stub network here. There's a router hooking into an ISP or a larger network, and so really there's only two routes that are required to get a stub network to work. This router needs a default route saying the rest of the world's that away, and this router needs to know how to find this network, and that's all you need to do. And so, stub networks, it works very well. And like our routers at home, they're a stub network. And so basically, as I said, you need a default route out on this router, and this router needs to know what network is on the other side of the router on the LAN. Okay, now, you can use static routes to connect to a specific network, connect to a stub router, or summarize routing table entries, which reduces size of routing advertisements. You can create a backup route in case a primary route link fails. So a standard static route is, so R2 has been configured with a static route to reach the stub network of 172.16.3. So, which of course is this network. So as I said, there were the two routes that are required, and so this is the one we're talking about. So you need to have a specify that is the destination network with its mask and how do I get to it. That's what you need to do. And of course, a default static route is what R1 needs to say the rest of the world is that away. Default route matches all packets and is used when a packet does not match a specific route in the routing table. Can be dynamically learned or statically configured. Default static route uses the quad 0 entry, and so it creates what's called a gateway of last resort. In this case, R2 is the gateway of last resort for R1. Common use is when connecting a company's edge router to the ISP network. The router has only one route to which it's connected. So you can also do summary static routes, and so you can have multiple static routes can be summarized into a single network address. And so destination networks, of course, need to be contiguous. They need to be a series of related addresses. Multiple static routes must use the same exit interface or next hop, so they're in the same direction. And so in the figure, it shows that you could actually summarize these 4 networks as just this one summary route, and that would explain all of them. And so instead of it being 4/16s, you could have 1/14 route. And so a smaller routing table means quicker lookups, of course. Now, floating static routes. So basically, here we've got, basically we've got a private WAN, and that is our preferred route. And so over that private WAN, you may well be running a dynamic routing protocol, and that's all great. They'll exchange routes, they'll talk to one another, no problems at all. But if that fails, you would like to have a backup route, basically. And so what you can do is, if you remember last time there was administrative distance, you can actually have a floating route with an administrative distance greater than your routing protocol. Often people use an administrative distance of 255, so as high as it gets. And so if you've got a route to the destination here with a 90 administrative distance, as they're saying, because they're using EIGRP, if that route fails, then you've got this other one that's been configured but ignored because it's got a 255 weight, or in the slide they're saying 91. And so because it's less trustworthy, it's not used when the EIGRP is working, but as soon as that fails, oh, I've got this other way to get to that destination, and so I'm assuming it's probably a VPN through the internet. And so that is a useful use for a static route, and so will only ever be used in the case of a failure. Okay, so how do we configure these things? And so the command for an IPv4 at least is IP route. And then from there, you need to specify the destination network address, the mask of that network, and then instructions on how to get to that destination. And so it's either a next hop IP address or the interface on this router that the packet needs to exit. I think we might have looked at this last chapter. And you can also optionally put in that distance. And so when we were talking about that floating static route, you could put in 91 or 255, whichever is your preference. And so that would actually be how you would put it in. And so that would be after the exit interface, you put the number. Okay, and so in this example, each router only has entries for their directly connected network. So we're looking at their routing tables. So router 1 has that network, and so you've got 2 directly connected networks, so 172.16.2 and 16.3. Router 2 has 3 directly connected networks, so the 2 serials and it's 1 LAN. So you've got 3 directly connected entries there. And router 3 is similar-ish to router 1. It's got 2 directly connected networks. Must be includes C. So we've chopped out the L entries. And so 168.1 and 168.2. So they're the only ones that are on that. So of course, router 1 does not have an entry for that, or that. It's only got 2. And so you might need some extra information. And so if you try and ping this the router there or the host there, you will actually not succeed because the router will go, I don't know how to find that. destination. Because there's no default routes, it will just toss the packet away. And so to put in an entry, you need to, of course, you need to specify either a next hop IP address or an exit interface, or you can actually do both. So on router 1, as I said, there are 3 networks it doesn't know about, so this isn't directly connected. This one and this one, those 3 networks are not directly connected, and so you can put in the IP routes for those 3 networks. And so from there, IP route, destination network, mask, next hop IP address, and they're all the same because they're all going via router 2. And so these are, of course, next hop IP addresses. Now, there is a downside to these next hop ones. They will work on every type of interface, but the downside is it then actually has to do a second route lookup to find out what interface that IP address belongs on. And of course, we can look at it and think it's S000, but you know, a router's a computer. It's not that smart. And so we can also do. So basically, with the next hop, we've got this entry here. Or was it this? Oh, sorry, it's that entry there. It's got a next hop, and so then you actually need to look up 172.16.2.0, and then okay, that's out S000. So that's actually a second lookup that it has to do on a routing table, and so it's not the quickest way to go. And so you can do exit interfaces. They're actually treated as a directly connected route. And so if you remember from last time when the administrative distances, static routes like this had an administrative distance of 1. A directly connected network has an administrative distance of 0. And so basically, in this case, it would work perfectly and it would work quicker. But the problem with the exit interfaces is if that exit interface is a LAN interface, it actually won't work because it needs to know the next hop so it can then figure out the MAC address, and so it's not good enough. And so your multi-access networks, you need to have a next hop IP address. Now you can, and so you don't need to do, so basically the directly connected static route doesn't have to do a second lookup. Now, you can actually do a fully specified static route. And so the beauty of that is it knows the next hop and it knows the interface. And so that's the best of both worlds. That will work on every interface and does not need a second lookup. And so both the exit interface and next hop IP address are specified, and so there's enough information in that one line that only needs to do one lookup. So that is another way to do it. So verifying a static route, well, basically you'd probably start pinging as soon as you've got all your static routes configured. But of course, yeah, you just show IP route static, and that will just show you the static routes. Okay, so a default static route, I think we did mention this last chapter. Again, so it's IP route, but the destination network is all zeros. The mask is all zeros, and then again you specify either an IP next hop IP address or exit interface, or you could do both. And so default static routes can be used regularly, either for stub networks or actually on a larger network. And the beauty of that is you can actually have it on, you define it on one router, and then you can actually get the routing protocol to advertise it to all your other routers. And so you only have to do it once. And so basically, a default route will match any destination address. Now, basically, the longer the match, so in other words, the longer the mask, the better the match. And so that's why this is a gateway of last resort. So it's the worst match. It's a match, but it's the worst match. So how do we configure it? IP route quad 0, next hop IP address. And so now if you don't have an entry in the table, so you could actually get away with just that one default route, and that will be all router 1 would need, because it only has the 2 directly connected networks. All others, I'll just send it to router 2. And so that'll work fine. You could do the same on router 3 as well at the moment as well, but router 2, you'd have to have specific routes because there's more than one way it could go. Now, so you can show IP route static, and it will show you the default route as an S. And of course, it also has the star, which says it's a candidate to be the default route. And if you see a gateway of last resort is something, that means that you do have a default route. If there's no default route, it will say gateway of last resort is not set. Okay, so IPv6 routing commands are as similar as they could be. Basically, IPv6 route, you specify the network number. Of course, we don't use a subnet mask with IPv6, we use a prefix length, so that's slightly different. And then again, next hop IP address or exit interface, or both. Now, for routing to work on an IPv6 router, you actually have to turn it on. It's already turned on by default for IPv4, but IPv6 you need to turn it on. So, with IPv6, it's not greatly different. Of course, the addressing is just different. That's the major difference. And so, as you can see, this has only got 2 directly connected networks. This one's got 3, this one's got 2. Or 2, 3, and 2. Same topology, just IPv6 addresses. And so again, we can have a next hop IP address, we can have an exit interface, or we can fully specify. The last one is probably the best option. And so again, there are 1, 2, 3 networks that are not directly connected to router 1. It needs 3 static routes. Router 3 would need the same, and router 2 would need 2 static routes for the 2 networks that aren't connected. And if you look at the routing table, again, they're marked as S, and away you roll. And so, with an exit interface, you don't need any extra lookups. And so, as you see, it says it's directly connected. Now, when it comes to routing, normally you will use link local addresses. And so, as you can see here, FE80::2, because this is on router 1, and as you can see, that's the link local they've got. And so show IPv6 route, and so link local addresses are normally used. And so show running or show IPv6 route. Now, default routes are typically shorter than in IPv6 than they are in IPv4. So, of course, this : /0 is equivalent to the quad 0 in IPv4. So, of course, 2 colons means 128 zeros. /0 is the prefix length, and so that means the entire internet. So again, address or interface or both. So here's an example. So IPv6 route, and then the entire internet, and then a next hop IP address. And so it's more efficient in this topology because, yeah, router 1, everything's that way. That's not directly connected. Router 3, the same. Of course, router 2, you'd have to do the statics. So that, of course, means no bits need to match. Again, it's a match, but it's just the worst match. And so that's what it looks like in the table. It doesn't give you a star. It also doesn't do gateway of last resort in IPv6. Now, floating static routes. And so most static routes have an admin distance of 1, and so they will actually overrule EIGRP. And so if you make the admin distance greater than whichever routing protocol, I'd normally do it greater than 120, just so it'll be floating above all routing protocols. And so the static route AD can be increased to make the route less desirable until the more desirable one is failed for whatever reason. So basically you can do IP route, quad 0, 5. And so here basically we've got 2 default routes. This is the preferred one. This is the less preferred one. And so if this one is up, that's the one we'll operate. If that one fails, then this one will come in because it's floating. And so this will have an admin distance of 1. This one's got a 5 because that's what's been set. And so it will only be active if this one is not active. So that's what normally happens. Okay. And so you can do a trace route to see how it connects to it. And then you could possibly unplug a router or something like that. We'll shut it down and then see what happens. Okay. And so as you can see, this routing with the interface shut down, you can see that it's got the admin distance of 5. There's no metric for static routes, of course. And so as you can see, that's the way it works. I would probably do the trace route from the PC, make it a little more interesting, but anyway. And so IPv6 works exactly the same. Just put the admin distance on the end, just like that one. You can put in host routes as well. And so, of course, a host route is a 32-bit mask with IPv4, and of course, a 128-bit mask for IPv6. So a local route, of course, is what it will come up with. And so IP route, destination IP address, mask of all 32 bits, next hop. And so here, much the same again, but of course with IPv6, the full address, 128 bits, and your next hop. So if you look in the routing table, you'll have the route to that, and in an IPv6 table, you'll have that route. And so here, the only difference is we've done a fully specified route. Okay, so how do we troubleshoot static and default routes? Okay, so static routes and packet forwarding. So if PC1 is sending a packet to PC3, it needs to go through all 3 routers to get there. And so, of course, first stop, the MAC address will be set for R1's MAC address, and then R1 will need to encapsulate it to get to R2. And then, of course, R2 reads it in and then forwards it towards R3. R3 receives the packet, decapsulates it, and then, oh, okay, I'm directly connected to the destination. And so it then has to look up, it's either an ARP table entry or do an ARP request to find the MAC address of PC3. And then it will forward it to PC3 out of G00, apparently. So, how do we troubleshoot a missing route? So ping, of course, ping will give us a binary answer, either yes or no. It works or it doesn't. While trace route will actually help us sort of approximately isolate where the problem might be, because it shows you every hop along the way. Of course, you can do show IP route to see if the routing tables are as they should be. And you can do show IP interface brief and show CDP neighbors also to do a bit of fault finding. So troubleshooting a missing route. So on R1, if you do a show IP interface brief, you can see that G00 has 172.16.3.1. That looks right. It's up and up. And serial 000 has 172.16.2.1. That looks right as well, up and up. So router 1 looks pretty good. And show it's got a routing table of. So who do we 2.1? And so we've got 172.16.1, which is that LAN. You've got another static for 192.168.10, which is that WAN link, and it's got 192.168.20 for the LAN. Show CDP neighbors, and so it's got, this is router 1, so it's got a neighbor of router 2, and it's got a neighbor of the switch. So router 1 looks pretty good. Okay, so we've got a routing loop here somewhere. So router 1 is forwarding it to router 2, but router 2 was forwarding it back to router 1. That is a bit strange. And so I'm assuming someone's put the wrong interface number on it. So 192.168.20 is going the wrong way. And so you'd actually have to remove that by doing the no IP route and then put in the correct route. So someone mucked it up. Okay, so chapter summary. And so we've looked at static routing. We've explained how static routes are implemented in a small to medium-sized business network. We've configured static routes to enable connectivity in a small, medium-sized business, and we've looked at troubleshooting static and default routes. Okay, so that's chapter 2. And so, of course, I will do a demo on WebEx on Wednesday. Have a good one.